This video is on Chapter 7, Part 1. And in the Chapter 7 videos, Parts 1 and 2, we are going to prove Theorem 45. And I'm going to prove Part 2 before I prove Part 1. And so Part 2 is that cosine of alpha plus beta is cosine alpha times cosine of beta minus sine of alpha times sine of beta. And so I'm going to do this basically, it's a proof by picture. So I'm going to start by drawing this triangle. Let me explain the parts of the triangle. So first of all, we took our angles, alpha and beta, and we put them right next to each other with a line segment between them. So we can do that. For convenience sake, for the sake of the algebra, I decided that the line segment would be of length 1. So we can extend this line segment any length we want, and we'll choose 1. After we do that, then we draw a perpendicular line to this line. So we draw our perpendicular right here. Now, we take this line segment, extend it as necessary to reach this line. We take this segment and extend it as necessary to also reach that line. So that's how we create this triangle, and that's why we can create this triangle. So now we have our angle alpha beta. We label this side A. The side opposite angle beta we label B, and then we label this side C and this side D. And now we're going to use right triangle trigonometry and the law of cosines to prove this trig identity. So to start with, we look at this part of it, and from our triangle, what is cosine of alpha? Cosine of alpha is right here adjacent over hypotenuse. So cosine of alpha is 1 divided by d. Then cosine of beta. What is cosine of beta? Cosine of beta is adjacent over hypotenuse, so it's 1 divided by c. That's cosine of beta. What is sine of alpha? Sine of alpha, opposite over hypotenuse, it's a divided by d. And finally, what is cosine of beta? Cosine of beta is opposite over, sine of beta is opposite over hypotenuse, so sine of beta is b divided by c. So we substitute right here. Our common denominator is c times d, and so this simplifies to ab minus 1 divided by cd. And we'll just sort of put a pin in that right here. And now we want to work with cosine of alpha plus beta. So now we're going to use the law of cosines. The law of cosines is going to tell us, so this is going to be the angle in the law of cosines. So our angle is alpha plus beta. According to the law of cosines, the opposite side squared, so that's a plus b squared, is equal to the square of the other one of the other sides plus the square of yet another side minus 2 CD, it's the length of these sides, cosine of the angle, which is alpha plus beta. So this right here is strictly from the law of cosines. All right. So now we take this and we start to simplify it. So we're going to solve for cosine of alpha plus beta. So we have our quantity a plus b squared. We FOIL this, and that's where the a squared plus b squared plus 2ab comes from. We subtract c squared from both sides. We subtract d squared from both sides. Then we divide by negative 2cd. And I forgot my negative right here. Okay. And my negative right here. I forgot those. Okay. So, alright. So we divided by negative 2CD. And so now we have this expression. Now what happens? Well, we know that a squared plus 1 squared is d squared. So a squared plus 1 is d squared. A squared plus 1 is d squared. So that means that d squared right here is a squared minus 1. And so a squared minus d squared is negative 1. Likewise, b squared plus 1 is equal to c squared. So b squared plus 1 is c squared. That means what? That b squared minus c squared right here is also negative 1. So to save space, I have negative 1 plus negative 1, that's the negative 2. Then we have plus our 2ab divided by negative 2cd. Then we divide by we factor out a negative 2 here, and it cancels with this negative 2. When we factor out the negative 2, that's why we have ab minus 1. And so this simplifies to ab minus 1 divided by cd.